Welcome everyone to TechDaily.ai. This deep dive is sponsored by Stonefly, your trusted solution provider and advisor in enterprise storage, backup disaster recovery, hyper-converged VMware, Hyper-V, Proxmox cluster, AI servers, SA365, a turnkey security appliance, public and private cloud. Check out stonefly.com for more info. Today, we're diving headfirst into a topic that, frankly, is often kind of invisible but carries an enormous weight: the environmental footprint of our digital lives. Specifically, cloud computing.
Right.
Think about it. Every email you send, every photo you upload, every, complex AI query you run it, all relies on these massive, often unseen data centers. And the surprising truth is their environmental cost has been largely hidden from us.
Pretty much out of sight, out of mind.
Exactly. But here's the exciting part. A really profound shift is underway, propelled by something called green cloud computing and the powerful principles of the circular economy.
Yeah, those are key.
So our mission today is to pull back the curtain and really explore how these ideas are not just reshaping the tech world for a sustainable future, but also actually cutting costs for businesses and benefiting society as a whole.
What's truly transformative here, I think, is that we're moving far beyond just tweaking things for efficiency.
Right.
We're looking at a fundamental reimagining of how cloud services are designed, delivered, and consumed. It's about directly linking those critical economic goals with our environmental responsibility.
A more holistic approach, then.
Exactly. It's a holistic approach that's, frankly, long overdue.
Okay, let's pull on that thread a bit. Our digital world might feel weightless, but it's anything but.
Not at all.
The global digital sector, and that includes all those data centers, the vast networks, even our personal devices, is estimated to contribute, a staggering 3–4% of worldwide greenhouse gas emissions?
That's right, 3 to 4%.
I mean, to put that in perspective, that's on par with the emissions of entire industrialized nations.
It really is. And stepping back to look at the larger trend, data centers alone gobble up roughly 2% of the world's electricity.
2% just for data centers.
Just for the data centers. But here's the kicker. The demand for digital services isn't slowing down. Not at all.
No kidding.
In fact, this energy usage is projected to double by 2030.
Double.
Yeah. So the critical question then becomes, how do we possibly sustain such explosive growth without completely overwhelming our planet's resources?
That hidden aspect you mentioned earlier is so crucial, isn't it?
Absolutely.
As a user, you just don't see the electricity meter spinning for the servers running your favorite apps.
Nope.
It's easy to forget that these aren't just ethereal entities. They're physical machines, often tucked away in vast facilities thousands of miles away, drawing enormous power.
And manufactured through incredibly energy-intensive processes, too. Let's not forget that part.
Right, the whole life cycle. It's like believing the water comes straight from the tap without thinking about the massive infrastructure behind it.
That's a great analogy.
So given this undeniable environmental challenge, a powerful solution is rapidly gaining ground. Green cloud computing. Now, this isn't just a trendy phrase, right? It's more than that.
Oh, much more. It's a comprehensive practice. It's about designing, deploying, and managing cloud services specifically to minimize their environmental impact across energy consumption, carbon emissions, and even that growing mountain of electronic waste.
Okay, so how did this whole idea evolve? It wasn't always top of mind, was it?
Not like it is today, no. The evolution is quite illustrative, actually. It really began taking shape, you could say, back in the early 90s with initiatives like the U.S. EPA's Energy Star program.
Energy Star, yeah, I remember that.
Right, promoting energy-efficient electronics in general. Then, by the 2000s, virtualization technologies, think solutions like VMware, became a real game changer.
Virtualization, right.
Yeah. They allowed multiple virtual workloads to run on far fewer physical servers. That dramatically cut down on power and cooling needs. When we talk about energy-efficient data centers today, a key metric we look at is PUE, power usage effectiveness.
PUE, okay.
A PUE close to 1.0 means almost all the power goes directly to computing, not cooling or overhead. And many leading providers now, they're achieving impressive PUEs below 1.2.
Below 1.2, that's pretty efficient.
It's a testament to these advanced systems, yeah.
And fast forward to today, it's not just a nice to have, it feels like an absolute necessity.
It really is. We're now seeing these hyperscale data centers, these enormous purpose-built facilities from major providers engineered for extreme efficiency.
So they're designed from the ground up for this.
Exactly. They're integrating renewable energy sources and even pioneering a truly innovative approach called carbon-aware computing, which we should definitely explore in a bit.
Carbon-aware computing. Okay, yeah, let's circle back to that. But first, what are the sort of tangible benefits here?
Well, the benefits are undeniably compelling. Beyond the immediate reductions in energy costs, which can be anywhere from 20–40% for businesses, that's significant.
20 to 40%, that's huge.
It is. Then there's the agility of flexible scaling, extended hardware life, and of course a significantly lower carbon footprint. But what's maybe a less obvious one, is there a surprising way businesses are leveraging green cloud?
That's a good question. You know, what often gets overlooked, I think, is the strategic advantage in terms of resilience and even talent acquisition.
Resilience? How so?
Well, companies prioritizing green cloud aren't just saving money on electricity bills. They're building more adaptable infrastructures,
Okay.
somewhat insulated from energy price shocks, right?
Okay, that makes sense.
Plus, for many organizations, it's becoming a key component of their ESG, environmental, social, and governance goals. And you find younger talent, especially, is increasingly drawn to companies with demonstrable commitments to sustainability.
The ESG factor.
Yeah.
So it's not just good for the planet, it's actually good for business reputation and, long-term viability.
Good point.
So with all these technological advancements, what does this actually mean for the fundamental way we approach business? Traditionally, our economy has operated on this linear model: take, make, waste.
The old way.
We extract resources, manufacture products, use them, and then, dispose of them. But that model is just not sustainable, is it? Not on a finite planet.
Precisely. It's fundamentally flawed in the long run. The critical question then becomes, how do we transition to a truly restorative, regenerative system?
And that's where the circular economy comes in.
Exactly. The answer lies in the core principles of the circular economy. It's built on a foundation of, reduction, reuse, and recycling, but also crucial concepts like enhancing performance and, most importantly for our discussion today, access.
Access. Okay, tell me more about that. How does access fit into cloud computing?
Well, that concept of access is where cloud computing really shines within a circular model. Think about it. Instead of buying and owning physical servers that might sit idle.
Which happens a lot, right? Underutilized hardware.
A huge amount. Instead, you essentially access the functionality of computing resources as a service. You pay only for what you actually use, sharing those resources with countless other users.
So it's inherently more efficient.
Inherently. This model drives more sustainable consumption because it optimizes resource utilization on a massive scale.
Okay, so it's shifting from ownership to access.
That's the core idea. And to truly grasp how this reshapes business, we can maybe briefly look at a framework like the business model canvas. Osterwalder, Pigneur, and Tucci.
Ah, yeah, the canvas.
Right. It helps visualize how a business creates and delivers value. In a circular cloud model, the value proposition moves from selling physical stuff to offering a shared pool of resources. That reduces upfront capital costs for customers.
Turns fixed costs into variable ones.
Exactly. And that opens up entirely new customer segments. Small firms, large corporations, public bodies who don't want the headache of managing vast data centers.
Makes sense.
And fundamentally, your cost structure and revenue model becomes service-based, aligning perfectly with that pay-per-use access principle. It's a powerful way to see the economic engine behind this sustainable shift.
That's a really helpful way to contextualize it. It sounds incredibly promising in theory, but how are companies actually implementing this, in the real world? This is where the strategies get really interesting.
Definitely. One of the most significant strategies involves creating truly energy-efficient data centers. And this isn't just about, turning off lights when you leave the room.
Right, it's got to be more than that.
Much more. It's about constant hardware upgrades, deploying advanced cooling systems like liquid cooling right on the server racks.
Liquid cooling, wow.
Yeah. Or even strategically locating data centers in naturally cool regions like Scandinavia to use outside air or even seawater for cooling.
So using the environment itself.
Exactly. Imagine the energy savings when nature does most of the heavy lifting for your climate control.
Okay, that's smart. What else?
Another major lever is virtualization and containerization.
We touched on virtualization earlier.
Right. Think of it this way. Instead of one physical server running just one application, these technologies let you run multiple applications or workloads on far fewer physical servers.
More bang for your buck, energy-wise.
Precisely. Technologies like Kubernetes, for instance, are masterful at incredibly efficient resource packing, just cramming more work onto less hardware. That translates into enormous energy savings.
Like having a dozen virtual offices in one physical building.
That's a good way to put it. And then A hugely impactful strategy is renewable energy integration.
Okay, so powering them differently.
Exactly. Major cloud providers are making massive investments in large-scale solar farms, wind power, geothermal, directly fueling their operations. It's about moving away from fossil fuels.
A direct decarbonization step.
A very direct, tangible step.
Now, this next concept you mentioned earlier, carbon-aware computing, that really blew my mind when I first learned about it. Can you walk us through how software actually becomes aware of its carbon footprint? That sounds futuristic.
It is pretty brilliant, isn't it? But it's happening now. It means your software isn't just optimizing for speed or cost. It's designed to understand its carbon emissions and then actively adjust its behavior to minimize that impact.
Okay. How does it do that?
There are a few key approaches. First, there's location shifting.
Location shifting.
Yeah, where non-urgent data processing gets routed to data centers that are currently running on the greenest available electricity grids. So it checks the grid's carbon intensity.
So it shops around for green power, essentially.
Yeah, kind of, yeah. Then you have time shifting. This means running those non-urgent jobs like, say, a huge machine learning training task during hours when renewable energy production, like solar or wind, is naturally at its peak.
Run it when the sun's shining or the wind's blowing.
Basically, yes. And finally, demand shaping. This is where the software actually performs fewer tasks or scales down its operations during periods when the grid is relying heavily on high-emission sources.
So it throttles itself back if the grid is dirty.
In a way, yeah. It's like the software literally thinks about the grid's greenness before it decides where and when to run a task.
Wow, that's a level of intelligent automation I hadn't fully grasped. It makes perfect sense, but it's genuinely exciting. But okay, that raises an important question. What about the hardware itself? We've talked a lot about the power it consumes, but what about the energy used to make the servers in the first place?
That's a crucial point. Absolutely crucial. What we call embodied emissions, that's the carbon footprint from manufacturing the hardware and then eventually disposing of it. That can account for a massive chunk, like 75–85% of a server's total lifetime carbon footprint.
75 to 85%, just from making and disposing of it.
Yeah. And given that data centers typically replace servers every, 4 or 5 years?
Pretty short lifespan.
Right. So optimizing hardware utilization, pushing it ideally to near 100% capacity, becomes absolutely paramount to reducing that embodied carbon. You want to wring every last bit of value and processing power out of each piece of equipment before it's retired.
Maximize its working life.
That's exactly. And beyond that, we're also seeing edge computing gaining significant traction.
Edge computing. Processing data closer to the source.
Precisely. Think sensors, smart devices, local networks. By processing data closer to where it's generated, it dramatically reduces the distance that data has to travel across networks.
Which cuts down on network energy consumption.
You got it. And sometimes the simplest things work too, just product longevity. Making the physical equipment last longer makes a huge difference. The longer a server performs efficiently, the fewer new ones need to be manufactured.
Right, less take, make, waste.
Back to the circular idea, yeah.
So, with all these innovative strategies in play, who's really leading the charge among the major cloud providers? We've looked closely at the big three, Google Cloud, Microsoft Azure, and Amazon Web Services. What are you seeing there?
Well, what's truly compelling here is observing their distinct approaches. It's not uniform. Google Cloud, for instance, really stands out as a genuine pioneer in this space.
So,
They achieved 100% renewable energy match for their global operations way back in 2020.
2020, okay.
Effectively making their operations carbon-free on an annualized basis. They use that AI-driven cooling we mentioned, boosting efficiency by up to 40%, and they seem deeply committed to a circular economy for their data center equipment, focusing on reuse, refurbishment, responsible recycling.
And they're reporting transparency.
That's another strong point. Their carbon footprint dashboard, launched in 2021, is often lauded for its detail. Crucially, it includes both market-based and location-based Scope 2 emissions, that's for just electricity, and importantly, Scope 3 emissions by default.
Scope 3 being the tricky one, the supply chain stuff.
Exactly, the whole value chain.
Yeah.
And they provide monthly updates. So pretty granular and timely data.
Okay, so Google's setting a high bar. What about Microsoft Azure?
Microsoft Azure also has incredibly ambitious goals. They're aiming to be carbon negative by 2030.
Negative, not just neutral.
Carbon negative. And they aim to power their data centers with 100% renewable energy by 2025. They've even committed a staggering $1 billion to carbon removal technology.
$1 billion, wow.
Yeah. And like Google, they offer powerful tools like their emissions impact dashboard to help customers track their own footprint. And it also typically includes Scope 3 emissions with monthly updates. So strong on goals and transparency too.
Okay, so Google and Microsoft seem quite proactive. What about AWS? They're the biggest player, right?
They are. Amazon Web Services, AWS, has made a commitment to 100% renewable energy, though they haven't specified an exact target date for achieving that goal across the board.
No date set yet.
Not a specific global date, no. Their parent company, Amazon, has the broader climate pledge, aiming for net zero carbon by 2040. AWS launched their AWS Customer Carbon Footprint tool in 2022, but it has historically lagged a bit in transparently, including those Scope 3 emissions.
Ah, the supply chain piece again.
Right. And they also tend to provide less granular data, often with quarterly updates rather than monthly. This can make it harder for customers to get a complete, really timely picture of their environmental impact.
So less transparency, potentially.
It's been a point of discussion, yeah. The level of detail and frequency has been less comprehensive compared to Google and Microsoft, which has led to some concerns within the industry about the full scope of their reported sustainability efforts.
And that's a truly critical point for you, the listener, isn't it? When you're making choices about your cloud provider, this level of transparency
Absolutely.
and their commitment to comprehensive reporting, it directly impacts your own company's sustainability reporting and goals. If your provider isn't giving you the full picture, it makes it much harder for you to accurately report your own footprint.
You can't manage what you can't measure accurately.
Exactly. Now, all of this sounds incredibly positive, and it largely is, but it's important to acknowledge it's not all smooth sailing, right? There must be challenges.
Oh, absolutely. It's not without its hurdles. We still face pretty high implementation costs for some of these cutting-edge green technology.
It costs money to go green initially.
It often does. There's also a definite lack of specialized expertise in the market, people who really understand how to design and manage these green systems. And of course, there's the ongoing risk of companies making vague sustainability claims without verifiable data.
The dreaded greenwashing.
Yeah, greenwashing is a real concern. You need robust data and verification.
And what about new demands, like AI?
That's a huge one. Stepping back to consider the broader implications, the massive processing demands of emergent technologies, like generative AI models, present a new and considerable challenge.
They're energy hungry.
Incredibly, a single ChatGPT query, for example, consumes maybe 10 times more watt hours than a simple Google search.
10 times. Wow.
So as these powerful tools become more ubiquitous, their energy footprint will only grow. And there's also the subtle but significant rebound effect.
The rebound effect, what's that?
It's where as green cloud becomes more efficient and maybe cheaper, it might paradoxically just encourage even more overall digital consumption. So you save energy per task, but you end up doing way more tasks.
Ah, so the efficiency gains could be eaten up by increased usage.
Potentially, yeah. It's something we need to watch carefully.
Okay. But despite those challenges, looking ahead, the future trends still seem pretty exciting, right?
Oh, definitely. AI-driven efficiency, for instance, is only going to become more sophisticated. It'll optimize everything from data center operations to network traffic in ways we're just starting to explore.
Using AI to make AI greener, essentially.
Kinda, yeah.
Mm-hmm.
We're also seeing the emergence of global green standards, which will bring much-needed consistency and accountability. Decentralized infrastructure like edge computing will continue to grow, further reducing data travel.
In government involvement.
Crucially, yes. Governments are stepping up with more incentives and regulations to encourage widespread green cloud adoption. Policy plays a big role here.
And we are seeing real-world results already, aren't we?
We absolutely are. Real-world examples show truly tangible results. You mentioned Apple. Their cloud infrastructure is 100% renewable powered. That's reduced its carbon footprint by over 40% since 2015.
40% is significant.
It really is. Unilever is leveraging Microsoft Azure's AI capabilities to optimize its supply chain, cutting an impressive 1.5 million metric tons of CO2 annually.
Wow.
And Walmart uses Google Cloud's carbon-aware computing to optimize logistics, successfully reducing delivery fleet emissions by 20%. These aren't just, incremental tweaks. These are significant, measurable shifts that underscore the potential.
Okay, so it's clear green cloud computing isn't some futuristic myth or just hype.
Not at all.
It's a powerful and rapidly evolving solution that is driving real environmental progress and offering compelling business advantages right now.
Right now, yes.
But the conversation certainly continues. Even with these impressive advancements, our planet's resources are fundamentally finite. So, here's a thought to leave you with. Will our collective, ever-growing demand for digital services eventually outpace even our best sustainability efforts?
That's the big question, isn't it?
There really is something for you to consider as you make your own cloud choices and navigate our increasingly digital world. Thank you for joining us on this deep dive. And before we go, just a reminder that our sponsor, Stonefly, offers robust and sustainable solutions. For instance, check out their 100 TB immutable and air-gapped SSO NAS for $8,995. It's an enterprise-grade solution designed to protect your critical data while addressing modern infrastructure needs sustainably. We appreciate you tuning in to TechDaily.ai, and we look forward to our next deep dive.